All right, be quiet. Let's start class. Today we are continue study the problems on study number theory. Okay, we'll discuss some problems on numbers. um, Problems on numbers. If we divide an integer by another number, right? So if a number n is divided by p, right? So what do you get? You will get quotient and you get remainder, right? So you get a quotient, right? It's called q, and you also got remainder, right? Be quiet. You get remainder. So let's write down the relationship among those four numbers, n, p, q, r. Okay? So when n divided by p, right, you get a quotient. But how do you express the remainder? You cannot just add r to the quotient. This still will be r divided by p. Right? So that's the first, that's the relationship. Okay. And so somebody not mute. All right. So we can rewrite this equation. We can rewrite this equation, you know, by multiply both sides by p. Okay. So n equals pq plus r. This is another relationship, right? It's the same. I can also move the remainder to the left. I bet qq. Now what I conclude, I find out the integer minus the remainder is going to be divisible by p. Okay, right? So whatever you give me the remainder, if I subtract the remainder from my origin number, then the number is going to become divisible by that by that number p. Okay, so here's a question. We're going to start. A positive integer divided by 5 has a remainder of 3. A positive integer, okay, and divided by 3, divided by 5 has a remainder of 3. Okay. My question is, what is the remainder when twice of the number divided by 5? Please don't talk. Okay, so what is the remainder when 2n is divided by 5? Okay, that's a question. Does everybody sign in? All right. So how do we solve this problem? You know, if this is a problem on the contest, right? You assume the answer is definite. Then you can choose a special value for n. Then you look at that. But there's a possibility the answer will be cannot be determined. Okay, it depends. Then if you choose a specific value for n, then you have a trouble, right? Then the answer will be wrong. Now let's look at the first. Assume the answer is definite. There's an answer here. So when n is divided by 5, has a remainder of 3. So n could be 5 plus 3, right? So which is 8. Right? Then 2n is going to be 2 times 8 is going to be 16. Okay. So you divide you can divide a 16 divided by 5, right? And what do you get? So you get 16 over 5, the remainder is going to be 1. But in mathematics, this is not a perfect solution because what happens if n equals another number, 23, for example, right? And do you still get remainder 1? So it's better to not assume the specific value for n, okay? So what we should do is, yeah, you may this is correct answer if you know there's only one answer there, but then we should try this following. N is divided by 5. N divided by 5 has a remainder of 3. That means n can be written as 5q plus 3, right? That's the most general form of this n. All right? So now you multiply by 2, that's 2n. Right. So 2n is going to be 2 times 5q plus 3. And you multiply this out. It's going to be 10q plus 6. Right? 10q plus 6. I can express it in another form. Will be 10q, 6 divided by 5 has quotient 5, remainder is 1. So I can group these two together. Keller, don't talk. Okay. So that will be 5 times 2q plus 1 plus 1. So you don't need to know the exact value of this. But 2n can be expressed as like 5 times something plus 1. So this will be the remainder. Okay? This is a quotient. But quotient is, it depends on the original quotient, right? Its original quotient is something, then you have. So this analysis gives you a good problem. You know, if I say a number divided by 5, its quotient is going to be 13. Okay. So what is the quotient when the remainder, when the twice of that number is divided by 5, right? Then you can use this formula. So let's look at this problem. Okay. If n divided by 7, okay, has a quotient 7, okay? What is the quotient if 2n is divided by 7? Okay, so you can this cannot be determined. Okay, so I need a, yeah, and the remainder of 5. Okay, so if I need that, if I have this information, then I get, then I can get a can solve the answer. This is pretty straightforward. You just need to know the relationship between between the original number and the quotient and remainder. Okay, so based on what we have, right? N is going to be 7 times 7 and plus 5. Okay, sorry. Right. So you just get the number, right? So that's going to be 49 plus 5, and it's going to be 54. So when you 54 divided by, when then 2n is going to be, now you have to deal with all those numbers, right? But you have to do computation. Now, I will show you a different way, not using this method. So it'll be 2 times 54, right? It's going to be 0, 8. Okay? Then you have to divide by 7, and you have to do the computation. So 108 divided by 7. So if it's divided by, yeah, So it's 108 divided by 7. Then the remainder is 3. But we can do that without the write on the details. You can, oops, yeah. Yeah, the remainder is 7, and then the quotient is 15. Yeah. Yeah, there you have to use the details. I don't have any other methods. So let's look at the next one. Right, what is the least positive integer that had a remainder of 1, but when divided by 3, and the remainder of 2 when divided by 4? Okay, so we are going to find the integer, the small integer. It has a remainder 1 when divided by 3, divided by 4 when its remainder is 2. So this n, if divided by 3, gives you the remainder 1, and if it's divided by 4, gives you the remainder 2. Okay, find the least positive integer. Listed positive integer n. Right? So, yes. Okay. So, of course, there are multiple solutions there, right? So, you can begin with any of the number, right? It's divided by, so use the first equation, condition. It'll be 3q plus 1, okay? It'll be 3q by divided by. Now, how can I use the second equation? And you just need to list all the possible solutions. The first one is the remainder is when q equals 0, it's 1. When q equals 2, 7. When q equals 3, it's 10. Okay? When q equals 4, 13. Okay? And 16. Right? So you have to check which one, when it's divided by 4, gives the remainder of 2. I think this will be the answer, because when it's 10 divided by, 10 divided by 4 gives the remainder, gives you remainder 2, because it's 8 plus 2. Okay, so that is easy to do. The next one, is slightly different. Okay, my question is, what is a list of positive integer greater than 3 and leaves the remainder of 3 when divided by 4, each of 4 and 6? So I want you to try. What is the list positive integer greater than 3 that leaves a remainder of 3 when divided by each of 4 and 6? Okay. All right. Okay, so it's divided by 4 and divide by 6 each time, and you get a remainder of 3. Okay, I'll give you a minute to think about okay, hold on. Let's see who is online and all right, Samuel, do you have answer? Sophia, do you have answer? Huh? 15. Anyone else? Karen, do you have answer? What's the answer? Right. So 15 is answer. Okay. How do we do this problem? We assume that number, right? When it's divided by 3, leaves a remainder of divided by 4 leaves a remainder of 3. So that's going to be divided by 4, right? Q. I'm going to use the first Q, right? And it's going to be 3. All right. So the next one, and this also implies, when n divided by 6, you have another quotient. So remainder is 3. So they have the same remainder. That's good. That means the first one, n minus 3, is divisible by 4. So here you also get n minus 3 is divisible, the same number, and is divided by 6. So a number divided by 4 and divided by 6, if and only if you combine them together, it's going to be n minus 3 is divisible by 12, not, okay? Because 12 is the smallest number, contain 4 and 6, right? So that means n minus 3 should be equal to multiple of 12. Let's call it 12m. But you're looking for the smallest, the least positive integer with this property. So that integer will be 12m plus 3. The smallest number n should be equal to 12 plus 3 and 15. Okay, this is what we get. Right? Similar problems I wanted to try is, so if you did not get this, what is the least positive integer greater than 1? That leaves a remainder of 1 when divided by each of the following numbers: 2, 3, 4, 5, 6, 7, 8, and 9. The remainder of 1. Right? Edward, do you have answer? No? Brian, don't have to. Have it. Joanna, do you have answer? Not yet?你笑定。Now, yeah, you haven't put. Yeah, if you forgot to write down your name, please do that when you leave. Okay. Daniel Liu. Who is Daniel? Huh? Anybody have answer? Huh? Okay, let's 100. No, it should be larger than that number, okay? I think Sophia has answer, right? Not yet? Okay, so the idea is the same remainder, so that means n minus that number is divisible by 2, 3, 4, 5, 6, 7, 8, 9. So the question is, how do you express, how do you express it, right? You just use one single number. So this is a divisible by one single number equivalent. So you see that you have a 2, 3, 4 is 2 square, 5, 6 is 2 times 3, 8 is 2 cube, 9 is 3 square. So I need a 2 cube, I need a 3 square, I need a 5, I need a 7. Okay, that's it. So this is n minus 1 should be divisible by the product of those numbers. Okay, the product of this number is going to be 2,520. Okay, so that is the reason, n minus 1 should be always a multiple of 2,520, and the smallest number is going to be this, 2,521. Okay. Okay. So this is the idea. It's similar to the previous problem. Just needed to find out the one single number which contains all those digits, like from 2 to 9. Okay, that actually is going to be 2,000. Smallest number, which is divisible by 2, 3, 4, 5, 6, 7, 8, 9, will be 2,520. Right? Okay. Let's try another one. Okay. So here's the definition. A whole number is said to be 9 heavier if the remainder when divided by 9 is greater than 5. If the remainder is greater than 5 when it is divided by 9. Divided by 9. Okay, some number divided by 9 is greater as a remainder. Then what is the least 3-digit 9 heavy whole number? Okay. Yeah, a number is called a non-heavier if it is remainder is greater than 5 when you divide by 9. And for example, you know, I'm not 3-digit, and like greater than 5, right? Greater than 5. I can give an example. 9 plus 6, 15, right? 15 divided by 9 and gives you, but this is only 2, you know, gives you the remainder. Remember, is going to be 6. So this is a 15 is a 9 heavy. Okay, 15 is 9 heavy. Okay, so 9 heavy number must be in the form 9 times q plus r. R could be either 6, 7, and cannot be 9 because the remainder is always less than the number 9 if it's divided by 9. Okay, so you only have 3 choices. The question is, how do you find the smallest 3-digit number? Karen, did you solve the problem? What's the answer? It must be 3-digit number. Right, the remainder is going to be either 3, 6, 7, 8 when you divide by 9, right? So I know that 9 times 10 plus 8 is going to be 98, which is more than 100, right? So the next number you can try is 9 times 11 plus 6, 9 times 11 plus 7, 9 times 11 plus 8. Okay, so the next number will be 105, so which is already 3-digit number. Okay, so the next, this should be the answer. You don't need to calculate the other numbers. So 105 when it's divided by 9, the remainder is 6, and this is I think this is the smallest 3-digit number here satisfying the condition. Now our next problem is trying to trim the larger number. Okay, here's a question: are we able to solve it? For example, I give you a very large number, and I'm trying to find the remainder. So if I give you the number like 7 to the 2018, okay, divide by I say divide by 5. What is the remainder? This will be very difficult problem, okay, because 7 to the 2018 is indeed a very large number, right? How do you simplify it? And to do this problem, I'm going to give you the ideas called the trim a large number, right? So the idea is I'm going to introduce some notations, right? So for my first notation is if you have 2 numbers, okay, they are related by by something like that. So when you divide by, if that gives the same remainder when divide by p, okay, then I say they're almost equal, the same. Here's the definition. When this is not equal, okay, I put the module called P, okay, if, okay, they have the same remainder when divided by P. When divided by P. Okay. So they're not equal, identical, but they are, when we just talk about the remainder, they're the same, okay, in this sense. So for example, 13, okay, when 13 divided by 9, the remainder is 4, right? But this is also equal to, yeah, let's say, let's find the two examples, module of 9. Okay, when 13 divided by 9, and actually the remainder is 4. Another number is 22. Okay, so in my eyes, 22 is the same as 13 if regarding the with respect to the remainder, because 13 divided by 9, the remainder is 4. 22 divided by 9, the remainder is also 4. Okay, so we just use this simple notation. Okay, and then using the 21 as the same remainder as 9 if when divided by 6. Okay, the remainder is 21 divided by 6, the remainder is 3, and 9 divided by 6, the remainder is also 3. Okay, using this, then we have some rules to follow. We have the following. We can prove that. Okay, if n has the same remainder as n bar when divided by p, m has the same remainder as n bar when divided by p, then n times m has the same remainder as n bar times n bar. Okay, and n plus m has the same remainder as this. Okay, you also have n to the certain power k has the remainder of this. Okay, so this is a this will help us to trim the number. Okay, why the last one is true? Because n to the first power k is just n times n times n. So that's the reason you can replace by another number. Okay, so here's the example. Okay, let's look at this example. Okay, right, we know 67. Okay, when it's divided by 7 or divided by let's say divided by I'm going to divide by 7. Okay, divide by 7, it is going to be 4, because if it divide by 7, okay, because 67 is a 7 times 9 plus 4, right? Yeah. So that means both numbers, when divided by 4, have the same remainder. Second one, 4 divided by 7 is, of course, has remain same. So then I claim that 67 to the 2018 is the same as, has the same remainder as this one when divided by 7. Okay, otherwise it's very hard to see it. You see that because both are very large number, but the remainder will be they have the same remainder. It's just too huge a number divided by 7. Okay, you can check that. Okay, so now let's look at the following problem. What is the remainder when 5 to the 24 is divided by 7? Okay, how do I do that? 5 to the 24, it's a larger number, right? And why when, yeah, so we call it, we trim the larger number. So 5 to the 24, you think about 5 to the 24, you will, yeah. 5 to the 24. I let you to try to think if you have any good idea to find out. Okay, using your own method. If you don't use this, yes, it's true. It's wrong. But don't guess. You know, of course, you only have a how many possibilities? It's a 1, 0, 1, 2, 3, 4, 5, 6. Okay. All right. Gosh, my pen has no power. I have to charge a little bit. So you have to think about this. I'll give you a minute to think about. Okay, 5 to the 24, right, is going to be right. You have to. You can 24 can be 12 times 4. Then would be 5. 5 squared to the 12th power. Yeah. Edward. Ah.
Yeah. What happened? What happened?
So we have another Edward. Edward Chen says 4. How come I have one more student here? Let me check. I did not see him. Oh, here, yeah, he joined us late. All right. Hey, Kellen, continue work on the problem. I don't know how to get it for. Okay. Yeah. Yeah, hold on. My somehow my I don't know what happens. My pen. I have to. It's not. Whoa, that's too bad. I cannot write on my screen. Yeah, my computer was broken. That's the reason I brought another one. And right now, it's the pen is not working. So, God, give me one more minute. And let me bring my file. Okay, hold on. Yeah, just a second. Okay.
I'll call your mom in New York. I'm going to some place and I will find I will tell your dad. I don't know, I figured I would take one of you and I'm sorry for you. Being Union jokes do not make you. Whatever.
Yeah, I need to bring up my my file because this is a. Hold on.
But if you have Snapchat, please add it. Yeah, remember when we were on the thing and you used to take your Snapchat screen? Oh yeah. I was like, I need to know what to take on. And then my dad got mine. Yeah. Your dad puts you on.
Yeah, dude. Okay, so I'm going to bring up my original file. Okay. Computer is. Yes. Okay. I have to use my written notes to discuss because my pen is not working. So the next problem I'm going to discuss is yeah. So this is let me explain to you. Can you see that? Okay. I have to bring up the original file. Okay. So my solution, let me explain to you. Okay. My solution is what? How do I do that? 5 to the 24 is going to be 5 squared to the power 12. Shh, be quiet. So 5 squared is 25. But when 25 divided by 7, what is the remainder? It's 4. So I trim the 25. Okay, I trim the 25 to 4. So I replace by 4. Okay, then 4 to the 12th power is still a larger number. But 12 is 2 times 4, so it becomes 4 squared to the power 6. 4 squared is going to be 16. So 16 to the power 6. But when 16 divided by 7, what is the remainder? 2. So replace 16 by 2. And the 2 to the power 6 is going to be, you can switch it, it's going to be 8 squared. But 8 squared is 64, right? 64 divided by 7, what is the remainder? 1. I don't know how to get it 4, but this is the idea, okay? Yeah, this is the idea. Sorry, my new computer is on the way, so I need the computer was broken, the screen. Okay, that's why I have trouble to write on that, right? So I have to use my written notes, okay? So the remainder is what? Okay, this is answer. So let's look at the next problem. Yang, can you enlarge it? Okay, the next problem I wanted to look at is, what is the remainder of 2 to the 75 power plus 4 when divided by 7? Okay, can you figure it out? We probably takes time, but let me explain to you step by step. Okay, so we have so first of all, we make such simple over there. That's my computation. Maybe not the best way. So 2 to the 75. 75 is not an even number. So I take 3 out. So be 8. Okay, it's 2 cubed plus 2 to the 72. So I keep 8 there, but it's 2 to the 72. 72 is a multiple of 4. Multiple of 4, right? So that's why the 4, 2 to the caret, it's going to be 2 to the power 16. 16 to the 18. Okay, 18 is large enough. Then what I'm going to do is I replace 8 by 1 because it's divided by 7. I replace 16 by 2 because 16 divided by 7 gives you a remainder of 2. Then 2 to the power 18, you do the same thing. 2 to the power 18 is 3 times 6. 3 times 6, 3 times 6, right? 3 times 6, that 3 is 8, 2 to the 3 is 8. So 8 to the 6. Okay, 8 to 6 is great because 8, when you divide by 7, the remainder is always 1. So you replace by 1. So that's the idea. You trim the larger number, and then step by step, you can quickly get remainder. Otherwise, nobody can do that. You can give this problem to even to your math teacher. I don't think you can do that. Okay, honestly. But the trimming, yeah, I will later on maybe show you why this works. Okay, trim larger number. You just need to look at the remainder. Okay, get rid of the rest of that. Replace this number. Right. So here, yeah. Then you add 4. 2 to the 75 plus 4 is just look at the last remainder. Remainder 1 plus 4, it's just 5. So the answer to the problem is 5, not just 1. Right. All right, so this is the next one. What is the remainder when divided by 6? 2 to the power 79. Yeah, 2 to the 79. Yeah, let me enlarge this. Yeah, 2 to the 79 divided by 6. All right, so when you see a problem like that, right, you still use the idea of the trim. Trim the large, 2 is already smaller than 6. You cannot trim it. So what they do is you can make a 2 to the power 6. 2 to the power 2 cubed. 2 cubed is 8. 8 divided by 6, the remaining is 2. So you can replace by that. But 79 is it even now? It's not it's a prime number. So you have to divide by, you have to separate, okay? You have to say 79 is going to be 2 times 2 to 78. But then the 78 is okay. 78 is you can divide by 2. You can divide, yeah. So when you divide by 2, it's still bad, this is going to be 39. 39 is, again, is, well, 39 is 3 times 13. Maybe use the 4 cubed, right? I did not use that way, but that's not the best way to do, not the unique way to do. And I still take the 1 out because I have to divide by 2. So 38 divided by 2 is 19. Then 4 square is going to be 16. 2 times 4 is going to be 8. But that's not a, there are multiple ways to can try. Okay, the multiple way can try. Then you will see that 8 is replaced by 2 just because just because 8 divided by 7 remain the divided by 6 is the remainder is 2. But 16 can be replaced by 4. just because 16 has the same remainder as a 4. Okay? Continue because 19 is even is an odd number, so you have to 19 is 18 plus 1. Then you do the same thing, you know, you take a 4 out, then 2 times 4 is 8. 8 divided by 6, it remains 2, so you replace 8 by 2. And the 16 is also can replace by 4. And then keep it going like that, and finally, and you will make the number smaller, smaller, smaller. Okay, 4 to the 9 is still a bad number. You know, you can take one out. It's 4, 2 times 4, then 8, 4 to the 8th power. But that's not a. This is this is just one way to do. Okay, you can also like a 39 at the very beginning. 39 divided by 3, right? Will be 4 cubed times 4 to the 13. So yeah, there are multiple ways to do. Then finally you get 2 times 4 is 8. 8 is still divided by 2, but 4 cubed is 4 squared to the 4th power. And finally,
Dr. Shen, nobody online can see the whiteboard.
Hello, what's your question?
Everybody online cannot see the whiteboard.
Cannot see them. All right. Yeah, I have a. Let me check. Oh, you cannot see the whiteboard? Hold on. That's weird. I can see it. Yeah, let me check, double check, okay? Oh, yeah, it was disconnected. That's weird. That's weird. I don't know what happens. Yeah, I think it's working right now, okay? The next problem I want to discuss. Yeah, so for this problem, after we try many times, we get the remainder 2, okay? Because 8 is divided by 6 is the remainder 2. So let's look at the next problem. So we want to see what is the last digit of 2 to the 1997. That was a math cons problem in 1997. You can change it to the 2018 if this is year. So we needed to know how to solve this type of problems. So let me explain to you. And this is a, the first method we try is look at the pattern. Look at the last digit, okay? We find out that 2 to the 1 is 2, 2 to the 2 is 4, and 2 to the 3 is 8, 2 to the 6 is 2 to the 4 is 6, because 2 is 16. Okay. So this is a pattern to repeat it. If you only write down the last digit, then 2 to the 5th, if you divide by the last digit will be 2 again, and 2 to the 6th is larger than 4. So it's repeating. That's one block, you know, a block of 4 digits, 4 numbers. So then finally, so 1 and 1997 actually is 4 times 49.9 plus 1. So there's a 499 blocks plus 1. So that's the reason the 1 should be so the last digit will be 2. This is the idea. Use a pattern. Okay. You write down the last digit of look at the first 5, 6, 7, like 2 to the power 1, 2 to the power 2, 2 cubed, 2 to the 4th power, 2 to the 5th power. Okay, then you will get just write down the last digit of the number, and you will see 2486 and repeat it 24686, and then how many blocks of 4 numbers there, right? For 1997. You divide by 4, then remain is 1. So there'll be 499 blocks plus 1. Plus 1. Okay? Right. How many times I call your name? Okay. All right, so the next problem is what's the last digit of this? Can you try this? 312 to the power 1997. Right? So it's 312 to the power 1997, and then we can view the last digit as a remainder when divided by 10. Okay, that's another point. Okay, so we can trim like that. 312 when it's divided by 10, the remainder is 2. So you immediately replace 312 by 2 and to the 1997. And the 2 to the power 1997, we already did that, so we just put a 2 here. You know, you can look at the pattern and then find out. So use the last example. I skip some steps here, but this is where you just trim. The idea is that trim the larger trim the, larger number to a smaller number. If we only consider the last digits or the remainder, and then you can always, you can drop the large, replace it by a small number. So my next topic, which probably is the last topic, is to discuss the base P representation of number. Okay, why we have to discuss that? We human beings normally use a called base 10 system to describe the numbers, because and we introduce 10 digits: 0, 1, 2, 3, 4, 5, 6, 9. So total 10 digits. The reason is because we have 10 fingers. I think if we only have 4 fingers on each hand, we probably use base 8 system to number the numbers, okay? And this will be weird. So in the future, when we're talking to the Aryans, maybe people living over there only have 4 fingers on each hand. I don't think that's any reason we need 5 fingers. Okay? And some animals do have 4 fingers on each hand. Okay, so then we have to understand how they are, the numbers we got from them will be different from the number. Okay, if they still use the same kind of digits, like from 0 to 8, so their 86 is not our, their 72 is not our 72. So we have to know how to convert them. So how do we describe a number using how do we express a base P numbers? Okay, use a base P. So if we have a number n, if we can express as this certain power, then we just need to copy down the coefficients, and then the coefficients will be like a AK, the first coefficient, second coefficient. I will show you example, and then put a sub P there. Those coefficients are called, put together are called the base P representation of the number. So let's look at the example. What is the base 2 representation of 9? How can I do that? So I'm going to express a 9 in terms of a 2 to a certain power. But the coefficients can be only 0 and 1. Right? So this is what I get. 9 is 8 plus 1. 8 is 2 cubed plus 1. So I can write down this in the more general form. 1 times 2 cubed, 0 times 2 square, 0 times 2 to the 1 plus 1. Okay, so I can write down all the coefficients 1, 0, 0, 1. And this 1, 0, 0, 1, okay, I use the same digits, okay? We use it for from our base 10 system, 0, 1, 2, 3, 4, 9. I can use the ABC, but normally we use the same digits. So 0, 1, 1, 0, 0, 0, 1, right? So I can use 1, 0, 0, 1 to represent the number 9. And I put sub 2 there because I use the base 2 system. Why this is useful? How about the computer? How can the computer record the numbers 9? No idea, right? When you design a computer, how do you record the number 9? Programming. The computer can only get the signals off and on, right? Off represents 0, on represents 1. So how, if we only can show 2 things, if we talk to someone across the river, right? And it can only send the signal on and off, right? How do you do that? And if you tell him 9 is number 9, you cannot say 9, 9, 9, 9. No, you cannot see it. You only see the lights on and off, on and off. So on means 1 means on, off means 0, right? Or use only 2 colors, red and white, right? Red means 1, white means 0. Then only red, white, red. Then this guy, oh God, number 9. Okay, so this is two different systems. We use only 2 digits here in the base 2 system by using 10 digits in base 10 system. But then we can translate them. Just like you speak Chinese and not speak English, you still need a translator. And in numbers, we do have two different numbers, even you use a similar digits, they look similar, but they're totally different numbers. Okay, 1001 is not 1001. Okay, it's equivalent to 9 in our base 10 system. Right? So let's look at the second number. What is the base 2 represent of 19? Okay, let's try and find out. So how can I do it? Well, in our base 10 system, 19 means 19, right? It's 10 plus 9, right? You have 19 apples, something like that. But the computers cannot record 19 directly, actually. You can type a 19 on the screen, but does not mean this is the way the computer understands. So how do I do that? 19 is 2 times 9 plus 1, because, right, 18. Then I continue. I replace 9 by 2 cubed plus 1 times 2. So I multiply this out. That'll be 2 to the 4th power plus 2 plus 1. Okay. So I have to list all those 2 to the powers. Even that's a 0, I put a 0 times 2 to the cube. 0 times 2 square. And then I can just write down 10011 sub 2. So for the computer, when you record a 19, it will be on, off, off, on, on. Okay? Okay. So 10,000, if I erase the sub 2, and you look like 1001, right? All right. So if you get signals from, suppose you land on another planet, and you look at the textbook, you figured out that they are using 2 digits only, okay? Either 0 or 1. Then you figured out, then you can quickly translate their numbers into our system, okay? Sometimes you see, oh, those people, aliens, only have 4 fingers on each side. So more likely they use a base 8 system to describe them, because you never see number 8. They are only from 0 to 7. 0 maybe use a strange symbol, A, and 1 use a strange B, and something strange symbol. Then you see a bunch of the numbers like that. And then you first of all, you have to identify which one means 0, which one means 1. And then all the numbers can be translated to our base 10 system. Okay, so here it's a base 2 representation of 19, right? Right. So I get 0. Now let's look at another one. Okay, what is the base 5 representation of 2031? 231. 231, I want to express in the base 5 system. Okay, it's not very useful right now. Yeah, because we either use a computer or we use our hands, right? Human being use a base 10 system, computer use a base 2 system. Maybe someday you find out you develop a new system using, it's better, even faster, right? So the idea is that I express 231 in terms of 5Ks with coefficients from 0 to 1 to 3 to 4. Okay, I still use the same notation for my 5 digits, 0, 1, 2, 3, 4. Okay, we're not going to create a new digits. You can, that's not easy. In Chinese literature, then do not use the 1, 2, 3, 4, this alphabet and those digits. That's why make Chinese so difficult to develop mathematics in history. Right there, write a 0, like, oh, many things, right? Remember, who can write down 0? Right? That's so type of, and the 1, 2, and now use the 2. You use those digits. It's simple. Just 2 means that, 3 means that. So quick. Okay. So we still use this, okay, to denote our digits for the new system. So what I get is 231 equals 2 times 10 squared plus 3 times 10 plus 1. Okay, that's in the base 10 system. All right, but 10 is going to be 2 times 5. So I replace 10 by 2 times 5. Then I do the multiplication. And I get, the first one is 8, because 2 times 2 times 2, 8. And 2 times 3 is 6. But that's not good, because 8 is larger than 5. 6 is also larger than 5. So I have to replace 8 by 5 plus 3, okay? And 6 by 5 plus 1. Then I multiply them out, and I get 5 cubed, 3 times 5 square, and 5 square plus 5 plus 1. All right, so what I get here, I have a 5 cube, 5 square, 5, no, oh, I have double 5 square. So you have to put together. So that will be 4 5 square, 1 5 1, right? Then the corresponding coefficients will be 1 4 4 5, right? So 231, if in the base 5 system, will be expressed as 1 4 4 1, okay? 1 4 4 1. Yeah, let's try another problem. Yeah, let's try another problem. All right, I want to translate the base of 4, translate the number in base 8 to base 4. There's a quick way to do that. First of all, 2 3 1 base 8 in the base 8 system. How can you read it as the same number in base 4 system? I think we can have an easy, quick way to do. All right. So the idea is that base 8 means 2 4 1. Base 8 means you can express it in that form, right? I want to express it in the 4th power, 4 to the certain power. Okay, this is the idea. So what I'm going to do is there's a shortcut to do that. 2 3 1. Okay, in the base 8 system is going to be 2 times 8 squared, 3 times 8, and plus 1. So the right hand side is a number in base 8, in base 10 system, in our system. Right? But I can multiply them out and then repeat the same procedure like before. But there's a shortcut because 8 is 2 times 4. Okay? 8 is 2 times 4. So I can replace it by 2 times 4. And finally, I get 2 times 2 square, 4 square, 6 times 4 plus 1. But the same idea, 6 is larger than 4, right? So I still have to replace it. It's replaced by 4 plus 2, right? But 2 squared is 4, so it becomes 4, replaced by 4. And finally, I get 2 times 4 cubed, and 4 square, 2 times 4 plus 1. So I write down all the coefficients in front of 4, and it'll be 2, 1, 2, 1, right? So the number in the base 4 system will be 2, 1, 2, 1, base 4. You see, you usually have more digits when the base gets smaller. From 8 to 4, you get more digits in the number representation, right? So this is the idea of 2, 3, 1 or base 8. That number now it can become 2, 1, 2, 1. Okay, 2, 1, 2, 1. Do I have other problem? Don't worry, we are delayed a little bit. Okay, yeah. I just want to quickly talk about last problem, 15. 12.15. So what is the base 3 representation of 251? So the idea is you have to express 251 in that form, right? And 251 is 251 is a number. You have to divide by. This is the way I do. Okay. First of all, you get this number, right? Right. 251 is 2 times 10 squared plus 5 times 10 plus 1. That's in the base 10 system. And 10 is going to be 3 squared plus 1. That's good, right? And so then you multiply this out. 5 is 3 plus 2. When you multiply this out, you get a bunch of this. Okay, it's 3 to the 4th power. You know, add them together. Some coefficients larger than 3. You have to rewrite it. Add them together. Like some coefficients here is 4, right? 4 cube, 4 square, 4 3 square, 2, and oh, there's 2 here, right? But so you regroup them and trying to express in that form. I get 2 for the first part, 3 square. Still bad because 6 is going to be 2 times 3. Okay, 2 times 3. So finally I got something like that. Finally, I got this 3 to the 5th plus 2 times 3 plus. So you will get in the base 3 system, you will get this long number 100223. Okay, that's the end of the count. So I'm sorry for the interruption of this at the very beginning. If you haven't signed your name, please put your name in. Next time, don't forget, okay? I will call your name. Yeah.
Who's near the door? Oh, the other door. Why don't I doubt you?
Oh, I have to give a receipt. Please give.
Somebody opened the door and they dropped it in.
Oh.
Well, that was actually fun. I remember it said
Okay, let me give you. Gosh, where's a pen? Okay. What's your name? So this will be another 10, okay? Yeah, I know.
Hello.
We're not gonna have a class in November on Thanksgiving Day.我的电脑晒破了。对，我用了这个另外一个电脑，那个 backup 电脑冬天出了问题，我只好用原来写好的投影。下我星期四到了，因为就那天就掉在地上以后，这个玻璃就碎掉了。来要修也来不及修，有时候没有 backup 电脑，对吧？这后面一个 lecture 我就直接就投影在我写的，跟他们解释一下。OK， 来，进 order 了。好，谢谢。